welcome. We're into the last section of electrochemistry, and they have given a staggering number of practice problems about this, so I will try to get through them with reasonable dispatch. Let's see how we do. The formula governing all of these is IT equals Fne. Some people remember this as it is fine or it is funny. I is current. Which is measured in amps. The unit is amperes, everybody says amps. That's the same as coulombs per second. The T is the time that passes with current flowing. And the time is always measured in seconds when you put it into this formula. So often in questions we will give you a time in minutes or hours. You'll have to convert it. Hours times 60 equals minutes. Minutes times 60 equals seconds. But it must be in seconds for this. F is a number called the Faraday constant, which is in your data book. It's 96,500 coulombs per mole. They might give it as 9.65 times 10 to the 4, same thing. And Ne is the number of moles, but not of just anything, of electrons. We've never really used moles of anything except for atoms and ions before, but now electrons are another thing we can count moles of. And keep in mind, in a reaction, if you have, say, zinc getting reduced, what this tells you is to make a single atom of zinc requires 2 electrons. So the ratio of electrons to zinc is going to be 2 to 1. Don't think this number is always the same as the amount of metal you're trying to make, or whatever thing you're trying to electrolyze. It can be 2 times as much, or 3 times as much, or even more, depending how many electrons per atom you're looking at. So think about this ratio when you're finding Ne. I'm sure we'll get some practice with that as well. So let's see what some questions look like. First one. They ask us for the moles of electrons, so Ne is to be found. They say we have a current of 0.1 amps. The time they give as 50 minutes. 50 times 60 is 3,000 seconds. I'll just say quickly, the correct abbreviation for seconds is just the letter S. In most scientific work, I tend to write sec just to make sure it's a little clearer and so it doesn't look like a little tiny 5. But be aware that sec is kind of an unofficial thing and a little bit of a cheat. So, if we start with our formula, IT equals Fne. We're trying to find Ne, so divide both sides by F. Number of moles of electrons equals how much current flowed times how long did it flow divided by the Faraday constant. So, in this question, it's going to be 0.1 amps times 3,000 seconds divided by the Faraday constant. 6,500. And from that, we get 0.003108808 moles of electrons. Significant digits. This has 3. 50 minutes has 3, and the Faraday constant, I seem to remember, is 9.65 times 10 to the 4, so that has 3 sig digs. Therefore, our answer can have 3, and we could round this to either 0.00311 moles of electrons, or scientific notation, we could move this 1, 2, 3 steps to the right and obtain 3.11 times 10 to the minus 3 moles of electrons. If you really like pain, you could call this 3.11 millimoles of electrons, but we don't use that much in this course, blessedly. So, hope that makes sense. Let's do many more of these. I'll get faster at them and explain a little less as we go on. And so we have, so they're giving us moles of electrons here. They tell us we have 0.072 moles of electrons. The time is 3 hours multiplied by 60, that's 180 minutes. Multiply by 60 again, that's 10,800 seconds. And they want the current. Formula is IT equals F and E. If you want the current, divide both sides by T to get current alone. F and E divided by T. So Faraday constant times the number of moles of electrons divided by time, that's going to be 96,500 times 0.072 divided by 10,800 seconds, and we get 0.64, lots of threes, amperes. 0.720 has 3 sigdigs, that has 3 sigdigs, the Faraday constant has 3 sigdigs, so our answer can have 3. We can cut this down to 0.643 amps. Good. Not too bad, right? Okay, 20 amps of current flows through an electrolytic cell containing molten aluminum oxide for 1 hour. What mass? Okay, now it gets interesting. Okay, we're making aluminum oxide. We'll get to that in a moment. This formula doesn't tell us anything about aluminum oxide. It just tells us, okay, we have 1 hour. That's 60 minutes. That's 3,600 seconds. And we know the Faraday constant. We can get the number of moles of electrons out of this. It'll be IT over F. Why? Because the formula starts out as IT equals F and E. You want N E alone, you divide both sides by F. F's cancel here, and you get number of moles of electrons equals current times time divided by the Faraday constant. So, current, 20 amps, times time, 3,600 seconds, divided by the Faraday constant, 96,500. We get, this is not the answer, 0.74611 moles of electrons. Now, they don't want the amount of electrons, they want the amount of aluminum. And the reaction we're doing here is we're turning aluminum oxide into aluminum metal, so we're taking aluminum ions. These used to be attached to oxide, but we don't care about that. We're just looking at the aluminum part. Aluminum ions pick up electrons like this and convert to aluminum metal. Why did I bother writing that? Because it shows us to make 1 aluminum atom, you need 3 electrons. More importantly, to make 1 mole of aluminum, you need 3 moles of electrons. So 0.74611 moles of electrons, we can say you get 1 mole of aluminum for every 3 moles of electrons involved. And that means we're going to get 0.2487 moles of aluminum. Molar mass for aluminum is 2698, so its mass is going to be number of moles times molar mass. 0.2487 moles of aluminum times 26.98 grams per mole gives 6.71005 grams of aluminum. Oh, small mistake here. Do you see what the trouble is? Why can't we give 3 sigdigs in this answer? This has 3, the Faraday constant has 3, but the time they gave only has 2 significant digits. So, down at the end here, we should only give 2 significant digits, and this, 6.7, is all we can give for our answer. So, I was under-caffeinated when I did that part of the key. Apologies for that. Student wishes to plate 10 grams of nickel into a hubcap from a mole per liter solution of nickel chloride. How long must the student run a 0.5 amp current to produce the desired mass of nickel? Okay, this one's unusual. They start us off with the amount of metal they want. So we know we're trying to use this formula, IT equals F and E. They tell us the current, 0.5 amps. We're supposed to find the time, so we're solving for that. We always know the Faraday constant. We don't have the moles of electrons, but we can get the moles of nickel. They've given us that indirectly. 10 grams of nickel. Number of moles would be mass divided by molar mass. 10 grams, and I'm not sure I remember the molar mass of nickel, so I'm looking it up. 58.69. 69 grams per mole. It's the molar mass of nickel metal, so 10 divided by 58.69 gives us 0.17039 moles of nickel that we're trying to make. It's coming from nickel chloride, so that means we're starting with nickel 2 ions. I don't care about the chlorides, just the metal. And we're converting those into solid nickel. Of course, there must be 2 electrons here. And we care about that because it means to make 1 nickel, you need 2 electrons. However much nickel you want to make, you need twice that many electrons. So if we want to make this much nickel times 2, we're going to get 0.34078 moles of electrons. Okay, so get the moles of your metal. From that, you can jump to moles of the electrons, probably by multiplying by 2 or 3. They'll be the same number if you're really lucky. And now that we have moles of electrons, we can finally get to our formula here. We're supposed to be finding an amount of time. So if we want t alone, we divide both sides by I. Sometimes I write my i's as a vertical line. Sometimes I put the bars on them. That's hopefully not too bothersome. Time equals the Faraday constant times the number of moles of electrons divided by the current. So 96,500 times our moles of electrons are 0.34078, divide by the current, which they said was 0.5 amps, and we get a time of 65,771. Time is always in seconds from this formula. So we get this. Now, if you tell anybody that something is going to take 65,000 seconds, they will think you're crazy. If you divide this amount by 60, that'll turn it into minutes. It's 1,096.2 minutes. If you tell people that something is going to take 1,096 minutes, they will also think you're crazy, so maybe divide that by 60 again, and it'll turn into hours. 18.2, well, 3 actually. 18.3 hours could be a reasonable answer. I suppose if you wanted, you could divide that by 24, and you could say 0.76 days, but decimal amounts of days are not all that comfortable to work with, so I think 18.3 hours is the nicest answer we can give for this. So, I hope those are going well. If they're not going well, there's like 3 more pages of these, and so if you want to look at some more, we will see you there shortly.